In this video, we are going to do these three questions from the trigonometric identities. It also involves application of some algebraic identities like a cube plus b cube. So let's begin with the first question. In this question, we have to prove that 2 times sin raised to the power 6 plus cos raised to the power 6 theta minus 3 times sin raised to the power 4 plus cos raised to the power 4 plus 1 is equal to 0. So the identity we'll be applying in solving this question is number one, we'll be applying this is algebraic identity called a cube plus b cube should be written as what? A plus b times a square. I may write b square first and then minus ab. So this is what we are going to apply here. Now, first thing that I'll do is to write sin raised to the power on the LHS. I can write this, say this is 2. I can write sin raised to the power 6 theta as what? Sin square whole cube. And likewise, I can write cos raised to the power 4 theta as what? Cos square theta whole cube. So as to apply the identity. And I'll open this bracket. Reason being, I'm going to get a similar terms inside. So we can open this bracket at this step only. So 3 when multiplied, minus 3 in fact, will be give you minus 3 times sin raised to the power 4 and minus 3 times cos raised to the power 4 theta plus 1 outside is equal to 0. This is outside, right, bracket. Not equal to 0 because this is what we have to verify. Now, as I said, we are going to apply this identity, and the identity I'm applying is over here, right? Over here, I'm applying this identity of a cube plus b cube. So this is 2. This is a cube plus b cube is what? A plus b. Well, needless to say that a is not sine, it is sine square. A plus b and b is what? Cos square theta. So a plus b bracket a square. So sine square, right? A square is what? Sine square whole square should give you sine raised to the power 4. You can write directly. Plus b square, and b square is what? Cos raised to the power 4 theta. Minus ab, and a sine square and b is cos square. That is, should be placed in 2 brackets, right? Now, this I should write below as it is. So it is minus 3 sine power 4 theta minus 3 cos power 4 theta plus 1. Now, what is sine square plus cos square theta is equal to? What we know that sine square plus cos square is 1, and 1 multiplied by any number is the number itself. So just opening the bracket, multiplying each of these term with 2. So it's going to be what? 2 multiplied by, this would be equal to everywhere. So 2 multiplied by sine raised to the power 4 is 2 times sine raised to the power 4, and then similarly 2 times cos raised to the power 4 theta, and 2 when multiplied by sine square cos square will result to give you minus 2 sine square minus 2 sine square dot cos square theta, and this being copied over here, so it will be 3 sine raised to the power 4 theta minus 3 cos raised to the power 4 theta plus 1. Now we have some like terms. As you can see that we have 2 times sine raised to the power 4 and minus 3 times sine raised to the power. So we can simplify, and 2 minus 1, 2 minus 3 is minus. So this is minus sine raised to the power 4 theta. Likewise, this when subtracted with this would give you what? Minus cos raised to the power 4 theta. And we have this to be copied as 2 sine square theta dot cos square theta. And outside we have a plus 1 over here. Next, I'm going to take minus common from here so as to apply the identity. So I took minus common, and this I'm writing as sine square whole square as to frame the identity of a plus b whole square. Since I've taken minus, this can be written as what? Same way, cos square theta whole square. Minus taken common here, so this become plus 2 times sine square theta dot cos square theta. The minus is taken common till here, right? So this will not influence plus 1. So now check what is this? This is a square plus b square plus 2ab, which can be written as a plus b whole square. A is this plus b, which is cos square theta. A plus b whole square plus 1. Now, once again, what is sin square plus cos square is equal to? That's 1. So I can write this as 1, and 1 square is 1 only, right? So just this minus sign from here, this is equal to minus from here, and this can be replaced with 1, and 1 square is 1, as I said, and this plus 1. So minus 1 plus 1 is what? 0, right? So this is equal to the RHS. Yeah, this is what we need to prove in this question. In this question, from the trigonometric identity, we have LHS as sin theta over cot plus cos⁴ and RHS as 2 plus sin over cot minus cos⁴. So there are two possibilities, two possible ways, I'll say that. One is to rationalize this by multiplying with cot minus cos⁴. That should result to give you what? Cot square minus cos⁴ square is minus 1. Alternately, we can also convert them in sin and cos. So let's go by converting them into sin and cos. So we are beginning with LHS, and LHS, this is sin theta that divided by, I'm writing cot as what? Cot is cos theta over sin theta. Is a plus sign, and cos⁴ is what? 1 over sin theta. Now check if I take LCM. LCM is what? First, I'll write down the numerator, which is sin theta that divided by, if LCM is right. This is LCM is sine only, right? So I can write this as cos theta plus 1 over sin theta. Later I can simplify this, taking sine above, so it becomes sine into sine, that is sin square theta, that divided by 1 plus cos theta, or cos theta plus 1 is same, cos theta plus 1. Right, so what is sin square? I can write sin square as 1 minus cos square theta, and below it is 1 plus cos theta. You can check over here that if I split using identity of a plus b, a minus b, so it's 1 plus cos theta into 1 minus cos theta, and that divided by 1 plus cos theta. So here 1 plus cos theta get cancelled. So we got the LHS in the simplified form, and that is 1 minus cos theta. Now I'll do the RHS on this side. On the RHS, we have 2 plus sin theta, and I can write cot as what? Cos theta over sin theta. And same way, it is 1 minus sin theta. This is 2 plus, if I take LCM, same way I can write directly as you have seen the working. So sin theta on taking LCM will be multiplied with sine. So it's sin square theta, and this is cos theta minus 1. This is 2. So this is equal to what? 2 plus, and I can write sin square as what? 1 minus cos square theta, as we did in the previous part, that divided by cos theta minus 1. So this is 2, and this is 1 minus cos square theta can be written as 1 plus cos theta multiplied by 1 minus cos theta. And below is what? This is cos theta minus 1. Check here, this is 1 minus cos theta, and this is cos theta minus 1. We cannot cancel them. If I take minus common, then it will become what? 1 minus cos theta. So this way now we can cancel them. 1 minus cos get cancelled. So what we'll get here? We have 2, and you see this minus sign will influence this. So it should become what? Minus. So plus minus is minus, and this is 1 plus cos theta. So now this is what? 2. If I open this bracket, 2 minus 1 minus cos theta. So that result to give you 2 minus 1 is what? 1 minus cos theta. So this is what? Our RHS, right? So we can see that the LHS and RHS are equal. So this is our RHS and this is our LHS. So this is how we will do this question. In this question, from the trigonometric identity is given that if 3 under root 3 cot square theta minus cot theta plus root 3 is equal to 0, then we have to find cot square plus tan square theta. Now, as you can see that clearly it is a quadratic equation. So we'll first solve this. What I can do over here is to let this cot theta as, say, x. I can take any other variable. So replacing cot theta or putting cot theta as x. So let's put it like put x is equal to cot theta. So this way what we are getting? We are getting root 3 times x square minus 4 times x plus root 3 equals 0. And now we'll do middle term factorization. Root 3 into root 3 was 3. From the factors of 3, 3 into 1 should give you 4. But then we need minus. So I'll take this as minus 3x minus x plus root 3 equals 0. So what I did actually, I did middle term splitting from in this part. Now what you can see that from root 3 and 3, what is common? Root 3 is common. So if I take root 3 as common, we'll get root 3x as common. So we'll get root 3 inside. This is x minus root 3. Similarly, if I take minus 1 common from here or minus 1 common from here, that will give you x minus root 3. As you know, on taking minus, the sign gets altered. So now taking x minus root 3 common from whole, we get these are the two factors. Now check if I equate this with 0, equating this with 0, we get x as what? Root 3. And equating the other with 0, we are getting x as 1 over root 3. Now we had to get, and x is what? X is cot theta. So now we can say cot theta has two possible values. Cot theta is either root 3 or cot theta is equal to 1 over root 3. Cot theta is root 3 when theta is how much? Theta is 30 degree. And the other cot theta is 1 by root 3 when theta is 60 degree. So we got the angle, and the two possible angles we got is 30 or 60. So now we are going to plug in these values over here. So let's say if I place cot as 30. So cot square 30 plus tan square 30. So this is 30, 30. So cot square 30, cot 30 is root 3. So it's root 3 square plus 1 over root 3 square. So this is what? 3 plus 1 over 3. So that is 9, 3 into 3, 9, 9 over 9 plus 1, 10, right? So 10 over 3 is the answer. Now, alternately, even if you place theta as 60 degree, right? Over here, when we place theta, this is theta only. When we place theta as 60 degree, we are also going to get the same answer, right? Because you know that next time it's going to be this as 1 by root 3 and this as root 3. So on placing, you are going to get the same answer. So we'll say that 10 over 3 is the answer for this part.